Hi students, in the previous class we have already learned the motion of an object in a straight line. So we have also learned the directional aspects of position, displacement, velocity and acceleration. And the direction of motion of an object is described either positive or negative sign. But in this chapter we are going to describe the vectors and we are going to describe the motion of an object in a plane. Or we need another parameter to describe the motion of an object in a plane. So that is we call as vectors. So in this chapter we are going to use the vectors to describe the motion of an object in a plane precisely, and so we are going to learn the language of vectors. What are vectors? What are their characteristics and how they are added, subtracted, multiplied, and first let us see what are vectors. And when we talk about the vectors, another term also come into play, that is scalars. Then there are two terms, scalar quantity and vector quantity. We might have heard in the lower classes. And what do you mean by a scalar quantity? A scalar quantity is a quantity that is a quantity need only the magnitude to describe the motion of an object completely. Okay, they need only magnitude. Then, for example, mass, volume, density, they all have the magnitude. Magnitude means a single number with its proper unit can describe the completely the quantity, and such a quantities are called scalar quantities. Then vector quantities. What are vector quantities? Vector quantity has both magnitude and direction. So, a vector quantity is a quantity that need both the direction and the magnitude to describe the motion of an object completely. So, they need magnitude and direction, both required, and there will be a specified number, and again also gives a particular direction of the motion of an object, and that describes the quantity of, for example, velocity, torque, acceleration, weight, electric field, magnetic field. These all are examples of vector quantities. It is not necessary that every quantity which has the magnitude and direction is a vector. But there are some other quantity and they have both the magnitude and direction, but they are not vectors. Then which quantity can be explained or described as a vector quantity? Not only the magnitude and direction, but also when they obey the vector law of addition. Okay, so when the quantity that obey the vector law of addition, then only they are considered as vector quantities. The scalar quantity that follows just the common algebraic addition, subtraction and all, because they do not have proper direction. But a vector quantity cannot follow a simple algebraic addition or subtraction. They cannot simply add or subtract by the way that we are doing in the algebra. So they have some rules or laws of vector addition and subtraction and other operations. How to write a vector? So in a printed books, generally a vector is represented by a bold face likewise. The letter may be, for example, force may be expressed as bold letters, then it is commonly considered as a vector. But while writing, we cannot, it is very difficult to make the bold letters. So generally for example, velocity, a symbol is placed, an arrow mark above the symbol, and then it is considered as a vector quantity. Velocity, force, and this is how we are expressing a vector quantity. Two types of vectors are position vector and displacement vector. So as we already seen that a vector is in a plane, so it has two axes, two reference axes x and y, and a common point called origin O. An object is placed at the point P. Okay, so this is the position of the object P. Then the straight line that joining from the origin to the position of the object, that this is the position vector. And now here we can write OP is the vector, okay, and also place an arrow mark on the head, and this arrow mark shows the direction of the vector. And now OP is the vector here, and this position vector, that is as represented as R. So OP is equal to R. Then now R is the position vector of the, and a position vector gives the straight line from the reference point, that is the origin, to the current position of the object, and that it is normally denoted by the letter, small letter R, and for this case OP is the position vector R. Now displacement vector, let us consider another graph, another reference axis x and y, and here we consider 2 points A and B. Okay, this is the point A and this is B. This is the reference frame or origin of the vectors. And now the position vectors of A, B can be described as, this is a position vector for A, that is written as R1, and this is the position vector of B, and that is represented as R2. Now the position of these two vectors of A and B, they are R1 and R2 respectively. Now we are going to see the displacement of these two vectors. The displacement of a two vector is the straight line that joining the final positions of the vectors A and B. Okay, so what is a straight line? The straight line joining these two, A and B. This is the straight line joining this A and B. So this gives the displacement of this vector. No matter what is the path length they took to reach the here, or maybe here, or likewise. Whichever way these two objects took the path to reach at this point B, then doesn't matter. So the distance between these two, the straight line that joining these two points A and B gives the displacement of that vectors. Or we may write this as R A B. Okay, R A B gives the displacement vector. There are different types of vectors, and some of the vectors we are going to describe now. The first one is equal vectors. One, when there are two vectors, they are traveling in the same direction and also they have the same magnitude. Okay, so these two vectors A and B, these two vectors, they are traveling in the same direction, and as the arrow mark indicates that they are traveling in the same direction, and both they have the same magnitude. These two vectors are equal vectors. Second, negative vectors. If there are two vectors A and B and they are equal in magnitude but they are opposite in direction, okay, one is going in this direction, another one is going in this direction. If their directions are opposite but their magnitudes are equal, then such vectors are called negative vectors. There are two or more vectors. All they starts from the same point along the same plane. So this is a vector A and this is another vector B. This is another vector C. This is another vector D. So there are two or more vectors. All they starts from the same point in a plane. Then such a vectors are called co-initial vectors. Then for co-planar vectors, as I said before, these are co-linear vectors, and co-planar vectors are if there are two or more vectors, if all these vectors are lie on the same plane, then they are known as coplanar vectors. Fifth, co-linear vectors. If there are two or more vectors, their magnitude may be different and their directions may be different. Okay, like this. There are two or more vectors. See, their magnitudes are same and their directions are same, and sometimes they are not same. So if there are two or more vectors, they are acting along the same line, they are known as co-linear vectors.